This is the Amp Hour Podcast, recorded July 8th, 2013. Episode 153, with guest Ryan O'Hara, Keyed, Kerfed, Kapton.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Chris Gamble's Analog Life.
And I'm Ryan O'Hara from O'Hara RP LLC.
Welcome, Ryan.
Hey, Ryan.
Hey, thanks, guys.
Thanks for joining us.
Every time I see your company name, I want to be like, O'Hara or Herb.
Oh, O'Hara. Yeah. Tell us the story with the name.
Yeah, so it's funny. Every time I get a phone call, I have to explain it to everybody. But
well rehearsed.
Right, yeah. So basically, a long time ago, network admin gave me, last name and first two initials for a login, and then, man, it kind of stuck. Especially when you have so many websites and forums, and I think the forums, the big thing is I felt like I was known as O'Hara RP, and then I was like, hey, I'm going to have a business, and guess what? I'm going to call it. So
yeah.
And then,
becomes an identity.
Yeah, my wife did marketing to her chagrin. She's like, you got to change your name. I'm like, it's too late.
It's what I'm known as.
Yeah,
Change your actual last name, you mean, at that point?
Just to just completely changing the business, and then
I see.
Yeah,
See, because I've heard stories in the past where like that kind of thing, where like that someone makes up a pen name, or they get. Or like Lane was been on the show before as well, right? And it's just like it just carries with you, And I'm sure a lot of people in the audience too. They've had similar network admin stories. Like actually, one of my friends, they cut off part of his last name, and people just started calling him that. It's weird, but it's just the world we live in now.
Yeah, and I just hate remembering passwords and user IDs, and so I just And then if anybody, when you're looking up URLs, like everything, all the good ones are taken. And it's like, so it's nice when you can actually go in and, you don't have to worry about, it's kind of unique. So.
And it's great on, forums. You're registering for, if you're like me, you're registering for forums every day for something new. And, I can use my own username because it's, fairly unique. And sure enough, almost every time it's, actually available, so it's great. You don't have to worry about it.
That is nice.
Works every time.
Not many other Chris Gambles out there yet, but maybe someday.
Right.
So, Ryan, what's your backstory? I mean, where do you? What have you been doing for the past life?
So I feel like I lead a double life. I don't have as many lives as you, Chris, though, with all 20 of your businesses, right? So
right.
just
I'm just trying things out, guys.
Yeah.
You'll succeed one day.
I think that's good, and that's kind of what. So I'm actually a military guy. I'm a active duty mechanical engineer in the Air Force, and I've done a lot of schooling. I went to the Air Force Academy, and then spent some time in Ohio. So when you were talking about Hamvention, oh yeah. So that's old stomping grounds there, and so
nice.
And then so did that, and then I recently just left Ohio. I got my PhD again, paid by the Air Force, so that was pretty cool, and I got to do some really neat. Micro air vehicle work. The Air Force was looking into this, and then there's some guys out at Harvard, Rob Wood's Micro Robotics Research Lab, and they're doing the RoboV. I don't know if you guys have, I'm sure some of your listeners have seen that.
Yeah, I've heard of it. Yep.
Yeah, it's those guys are.
It's like the ultimate scary thing, right. Robots just appearing in the natural environment. You're like, oh, it's just a little tiny bug, whatever. No.
Yeah, no.
But I'm sure there won't be any privacy concerns in the U.S. at any point. So.
and I don't know. I spent a good 3 years working on that, and even some of the stuff. Every time I go to look at their site, I was like, oh my god, I can't believe they just solved that. Some wicked smart guys out there.
So what is the RoboBee then? So it's it actually flies and it's robotic and
Yes.
everything like that. I mean,
So the concept is that you would have so right now we got a big question that came up was we already have small UAVs, right? And we got toy helicopters, right? So but I'm pretty sure if your toy helicopter was flying by your window, you know, and you're the bad guy, you'd be like, hey, there's a toy helicopter flying by my window. So if you could blend in, if you could blend into the environment, you know, so you look like a bee or a hummingbird or whatever it was, you would be, you know, be in plain sight, but you'd still be inconspicuous. And so that's the kind of the idea. But the actual
how many times were there bee jokes like running around?
So I actually worked with so my work was slightly. We worked with an insect called the Manduca sexta. It's the tobacco hornworm. It eats your tomatoes. But those things, those things turn into a big moth, and then the wingspan, each wing is about the size of your thumb, and so so we were looking at like a slightly larger class of micro UAVs, if you want to call that. And then so there's lots of moth jokes around, and then you know
So how do these flying insect / bird robot bee robots do in terms of
Well put.
thrust to weight ratio, if that's the correct term, you know, like, you know, flapping wing to weight ratio? Because if you look at a quad or you listen to a quadcopter, right, just to keep that bastard in the air, it makes an absolute terrible racket. It's, you know, it's phenomenally loud. It's got to spin at, you know, how 10,000 RPM or it's awful. Is it the same thing for these insect stuff, or is shooting for something, you know, as silent as a bird, for example?
Yeah, so they end up being really quiet. And then in terms of power to weight, you only need you know, like 1.1, you know, I think like an F-16 is only like it's got a thrust rate of, I don't know, it's like 1.05 or 1.1. So it's not that much to go vertical, right? And so
that's right.
So you don't really need that much, but it all comes down to payload, and then how big is your battery going to be, right?
Yep.
So
right.
So these things use piezo elements, and then that move back and forth, or bimorph actuator, and then
they're the things that simulate the wings, the wing structure.
They actually simulate the muscles that would be in the thorax of the insect.
Right. Yep.
And then and then the way the UAVs, at least these insects, work is there's the exoskeleton acts as the transmission. So instead of gears, you actually the muscles actuate kind of like an aluminum can, you know, and you have that spring back effect.
Yep.
So they collapse and then it springs back, so it's an elasto. And then
got it.
And then there's some other muscles, and then basically the wings and ligaments. But the exoskeleton acts as a transmission to transmit a small displacement at the muscles into a big displacement at the wingtip, right? And so so what these guys,
like power transfer kind of thing.
So it's basically just it's a bell crank slider. So it's just
whoa! This is an electronics podcast, Ryan. So you're in enemy territory for now until we start talking about your other stuff.
Right? Yeah. So, but what is cool is that, at least for my PhD, and then this is where my electronics came in really handy, is that the Harvard guys kind of came up with this, and we worked together. But we took thin film electronics, and so we used an LPKF laser, just like you would depanelize circuits. So if I hadn't had that background, I was like, we need to control these things with the laser, and I was like, well, I know a company that makes this stuff, and we originally started out with the LPKF router, but then wasn't finding enough detail, and then we spent some big bucks getting LPKF laser. Yeah, and then German stuff's expensive. That's what I.
Yes, it is.
Yeah, right.
What model is it that actually does the laser? I've seen them before, but I don't know the model name.
Yeah, so now we're getting all sorts of laser stuff. There's a proto laser U. So the U being for ultraviolet, or the 355 nanometer stuff. But what's cool about so for my business, we use a CO2 laser to cut Kapton stencils, but it basically, the wavelength of the laser, anytime you use a laser, physics come into play, and it becomes almost like a chemical process, and it's all about absorption and then absorption rates, and so the different wavelength, the different materials will absorb it differently, and then also about how fast you pulse your laser affects things. But basically with the CO2 laser and Kapton, I almost like am in the burning it phase because it absorbs it so much. But with the UV laser, you're actually ablating it ablating or ionizing the material versus heating it up and burning and charring it. So there's a difference. So
like it kind of it like heats up and kind of floats away, that kind of idea for ablation.
Yeah, and then but when it does it, there's no damage. It's very localized, right? And so it gives you a nice clean cut. So like for my stencils, I have to go back and have a mechanical cleaning process, which is me scrubbing it with a scrub brush and water. So whereas with the UV,
well, we'll get to the stencils. That's what Ryan's really here for. But we'll get to that. I want to hear more about this bee because this thing's crazy.
Yeah.
So what kind of control was in there though? I mean, so you said you had to get the features smaller, but like how small are we talking about here? Are we talking about like microns or what?
So 1 micron or 25 microns is 1/1000th of an inch, and then a human hair would be 3/3000ths of an inch or 75 micron, and you can machine on this. It had a set of precision galvos, and then also had a table, but we were 2 to 5 micron accuracy. And then, so which is important because so we did a number of different things. So this transmission is really what you're trying to build mechanically, and it happens to deal with a layers of carbon fiber, and then we would use a bond ply that's in flex circuits. It's basically a thin sheet of adhesive, FR 1500, but. Like if you had 2 pieces of Kapton for a flex circuit, you got to stick them together, and you don't actually glue them together, right? So you would use this. It's like a tissue paper, but it's glue. And then when you heat it up in a press and collapse it, it basically melts and bonds. And so we would use this and you can buy it in different ways. You can buy it adhered to Kapton, or you can buy it just on its own. But we do this multi-layer stack up, and that's what the Harvard guys do for this. And then you basically create a 3D structure. Akin to what a lot of the guys are doing with CO2 lasers and acrylic, or making a case or whatever. So you create this 3D structure, you sandwich it and cure it, and then if you're really smart about where you cut reliefs and do different things, you can actually. The idea was that you basically had carbon, glue, Kapton. You put glue again, and then another piece of carbon, and then if you cut away the carbon in the right spots, you could actually have a flex hinge. Just like a flex circuit, but instead it was a hinge, and now you've bonded it all together. So, well, we can put up some links and videos, but so I was working on our features were like in the 100 to 200 micron range, and then those Harvard guys are going in the 20 micron range, I guess. They're doing just like their features are ridiculous.
So is there actually like a control feedback system kind of thing going on in there, or is it just kind of an open loop?
Yeah, so this is
slap fast.
So for my stuff, I was kind of in an open loop, and when you're using these piezo actuators, they need lots of voltage, like anywhere from they would operate minus 150 to 200 volts or so, and then so you got to generate all that. So that's the big concern is power, right? So how do I get not only just a battery that's small, but how do I bump up the voltage?
Just drop a transformer on there. I bet that would be really light.
So luckily for my PhD work, I didn't have to focus on that. That's somebody else's problem. So
nice.
but so this is where, and this I thought it was pretty interesting on the show when Jerry was on and talking about different chips and with the metallized gate arrays, and there's some researchers working on control, but doing custom ASICs to and for feedback and all sorts of different stuff like that when you're controlling the wing. So because basically the idea is that you have 2 wings flapping, and then basically you can change the frequency at which they flap. You can change the amplitude, and then by doing it in it's kind of neat. There's a whole bunch of control theory. I'm not a huge controls guy, but I claim to understand a little bit. Is that you can have a few degrees of freedom, mainly frequency and amplitude. So so that's 2 degrees of freedom. But you can get, if the controls guys are real smart, you can get 5 degrees of control.
Oh wow!
So it'd be roll, pitch, yaw, and then up and down, and all sorts of different things. So you can do a lot with just 2 degrees of freedom in the control side. So that's kind of a cool.
Awesome.
I hate breaking down physical processes to like actual equations and stuff, because you're just like, oh, nature is so much better at this than we are.
And then that's when I was studying all this stuff, it was like, oh my god, this is pretty amazing. And my job as a mechanical engineer was the lift mechanism for these things is actually pretty complex. Like a traditional airplane, wing flows over one side and creates a pressure differential and you get lift. It's really simple, and we kind of are looking for non-linear, you're in the linear range. But with insects, they fly in the non-linear range, and so there's basically vortices that are shed off the wings that actually generate the lift. And then so it's like when you row a boat, and you put your oar or your paddle in and you pull it down along the side, and you see the little swirls. Well, that's what's generating the lift for these insects, and that is a completely non-linear. We can't model it. It's difficult to understand. And then, and I'm not a smart guy. So I said, hey, these insects have it figured out. So maybe I should just study what they're doing. And so my goal was to study the structure of the wing and be able to produce an engineered wing with the same properties as the biological one. And
biomimicry.
Right. Yeah, so it's total biomimicry. And then, so I was able to do it, and we generated just as much as biological analog, so it was pretty cool.
That's awesome. That's really cool. Yeah, I mean, you got to figure that evolution's been taking care of that for a couple million years,
Right.
So
is this still your ongoing day job?
No, so I've kind of moved on to that, to different things, and I'm in the land of the equivalent of corporate suck. So
I was like, please be designing dinosaurs. Please be designing dinosaurs.
I've Bob's came to where I work and said I need to go to upper middle management. So that's
oh no.
So luckily I have my business to keep me insane. So yeah.
Keep you insane or keep you sane?
Or keep me sane, right?
Sane.
Yeah.
Okay.
Yeah.
Good. Well, it sounds like you're doing some cool stuff though. So tell us about this side business. I mean, what are you doing with it, and how does it apply to robot wings?
Yeah. So I think the big thing is I had started my business in 2007, but I did it really, I don't know, I'm sure you have some listeners out there. I'm addicted to tools, or more locally now, development boards, right? Yeah. And then, it started getting really expensive, and my wife, of course, started to poo-poo that thing. So
I know the feeling. Yep.
Yeah.
Dave does too, I'm sure.
Yep.
But now it's a business, right? So it's
so it's like, well, if I want to buy tools, and then for a business, and so that's kind of what I started doing. Just originally was kind of like as a little write-off, and then I had some good ideas that I wanted to patent, and basically learned that patents are a bad idea. So what a giant waste, at least for a small person. If you're trying to patent something, it's expensive to do it, and then even if somebody did infringe on my patent, I'm like I had no money to sue them. So
exactly.
But well, then I think also too, and that's kind of early on. I really like the open source hardware. SparkFun had just started, and then Adafruit had just started, and different things. And I saw people were sharing a lot, and it's like, oh man, if you come up with some good products, there's no need to patent it. Just keep innovating, and I think that's the key.
Exactly.
Mm-hmm.
But
so you went with that. So you dropped all this patent rubbish, and
yeah. And then I had to develop a product. It was basically at the time it's just a GPS logger to an SD card, and but I did it for the stuff I was doing previously. It turned out some support work I had done was I made more money from the little side device than the actual product I wanted to make, and did that for a while. And prior to getting my PhD, I did on my application. I'm sure you guys see this a lot. I do quite a bit of consulting work too, so it's the business and the web page end up being kind of like a good showcase for, hey, look at all these cool things I can do, and then people come out of the woodwork and say, man, it'd be awesome if you. So I did a bunch of cattle tracking actually in Australia, right?
Oh, cool.
Oh, there you go.
Yeah, so we did some stuff with that, and then Did
you go out there?
I tried. I wanted to really bad. It just didn't work out. So,
that's good. There's lots of spiders.
Yeah,
They're scary.
and everybody talks funny down there. So,
yeah, that's true too.
Yeah,
crazy
weirdos.
But then, the coolest project though was a researcher in Norway contacted me about glacial monitoring. Like, he wanted to see how fast a glacier could move. Or that's what they were doing, and said, hey, it'd be awesome if we had a low-cost device. You know, it's actually interesting you talk about this. And I'm sure you see this a lot, Dave. There's like a total it's amazing what corporations will pay for equipment or certain devices.
Oh, yeah.
And it's like, so weather and research are ones where it's like, let's spend thousands of dollars on stuff. And I was
thousands?
Yeah, right.
That's petty cash
right.
level, you know?
Right.
It's
right.
tens of thousands,
right.
hundreds of thousands,
yeah, right.
you know?
Definitely. And so, so I think for like, I don't know, a couple $100, we put a bunch of basically little stations in, on a Norway or a glacier in Norway, and they operated for 6 months. And they have like a big light dark cycle. So once the sun went away, we had some problems, but we got some good data. So it's pretty cool.
I think they were solar powered at that point.
So we had a big like 10,000 amp hour lithium battery, so we could run.
Right.
So we could run for a couple. I don't know. I think it was like 2 weeks or so, and then you know, the solar power would augment that. So yeah,
cool.
It's too bad they haven't figured out the cold harvesting technology yet. That one's still in the works, folks.
Well, so I always
be great for glaciers.
I've always thought, you know, I think a lot of people think analog's like a black voodoo art, but I think power management is just like, whew, sometimes it can be crazy, you know, or you know.
You mean like sleep cycles,
yeah, like
and like actually managing
cycles,
when stuff is up and transmitting?
Yeah, transmit times, and you know, and people always want their stuff to run as long as possible for cheap as possible and the smallest size, and you're like, there's got to be some trade-offs. Right, and then they want like full bandwidth data too, right? They want you to be transmitting every minute or something. It's like, no. And then it's like temperature, and it's like temperature doesn't change that fast, you know? Like that kind of stuff is crazy slow. Yeah, no, I agree completely.
And then at lower temperatures, you lose your battery capacity, and
that too.
It just gets, you know,
right. And then horrible. Crystals and oscillations and so
yeah, it seems like a devil in the details kind of thing with optimizing for long life and long capture cycles and stuff like that. Because you're right. I mean, like the black art of efficient processing like that. Like, how do you test that too, right? That's the other thing. It's like, you know, you either have to sit around and wait for it, you have to accelerate it somehow, you know, like or you just have to go off your initial numbers of, well, our active state is, 10 milliamps, and our sleep state is, a couple hundred nanoamps or something, and then just extrapolate and hope for the best.
Yeah, well, then that's why, so back to Dave, like in the microcurrent, I wish I had one at my desk, but I've kind of, and that's the other thing too. I've debated kind of getting some of that stuff, but it's good to know. But then there's so many things, because once you move it, to the right 4 inches, it sucks, 10 more milliamps, or you actually install it at the customer's site. And you're like, oh, I didn't know the stars were aligned over here, and yeah,
gravitational pull, and right.
Yeah, but yeah, so I did a bunch of consulting work, and then so during this time though, I was getting really pissed off at turn times, right, and lead times for everything, and I was like, oh, so I get boards, but then you gotta, I've a big believer in surface mount, and I think the engineer in me always wants to, like, I was like, I know there's a machine that could do this, or so you know,
You are correct.
or there's a better process, you know. So so I looked at stencils and I could have ordered a few, and there, you know, at the time there was acrylic, or not acrylic, but I think it's acetate, you know, the clear stuff,
Right.
and then
Yeah.
but I was like, man, it would be really cool to have a laser, right? Because I'm addicted to tools. And then I was like, how could I justify this? And so
Yeah.
I said, oh, well, I'll make them for myself, and then this will be for the business, and I'll be more efficient. And then you quickly realize how expensive stuff is. And then, so this was 5 years ago. So it's big, you know, you're still looking at like $20,000 investment. And so I was like, I'm going to have to, you know, share this capability with folks, and so I tried to do that. And then no one at the time was offering Kapton stencils, so we started offering those. You can get a cleaner cut file, and it's a more efficient process. Yeah, so kind of.
So what are some of the other ones that are out there, right? I mean, so it's mostly aluminum is one of them, right?
Yeah.
And then you said also the acetate. Are there any other technologies that you're kind of competing
So
against?
the classic would be the stainless. Well, there's chemically etched stainless stencils, right? And you can do it one side or two sides. And I don't claim to be an expert in this. Other than that, you know, you get anytime you cut material, there's always a kerf, which is you know, like we use a saw, right? So there's material that's removed, and
It's the radius of the...
So,
yeah.
So, you know, chemical etching has different ones, and laser has a certain, and it's all about.
Are you talking about like the undercut, or what are you talking about here? Sorry, I'm not.
I guess it is
sure.
the undercut, right? When you chemically etch, and then they'll etch from they can from the top and the bottom too, to minimize that.
Oh, okay. So you're just talking about so if people are thinking about this as like cutting out an actual square out of a slab of material, you're saying that there's like bows in the walls then, right? That's the undercut or
Or the
overcut or whatever
corners
you're saying.
are rounded instead of perfectly
okay.
square, you know.
Well,
Yeah.
and then like if you wanted to cut like a 3D square with straight walls, you don't actually get that. The walls are actually angled, so you get more of like a 3D trapezoid, right? It's a like a draft angle would be the equivalent.
Getting into
Plastics,
plastics,
there you
huh?
go.
Yeah, go ahead.
No,
Sorry.
no, I'm sorry.
Because people might not know what draft angle is either, right? That's actually what it is when you have an injection mold, and then you can't have straight 90-degree angles because when you pull the mold out, then you'll start tearing at the plastic you just molded. And I only know this because I was just working with some people that know what they're talking about.
Right.
Well, then
It's awesome.
This is kind of a slight distraction. The proto mold guys, they have some like excellent tutorials on draft, and let's stay aside. But
good. Okay, I'll put that in the show notes.
But yeah, so you have their stainless, and then you can chemically etch. You can use a laser on the stainless, and then they'll go back and like electro polish them. And then I guess next would be acrylic, or not acrylic, excuse me, Kapton. And you can cut those with different types of laser. UV would be the best ones, and then just because we talked earlier about the absorption rate and clean cuts and different things, so UV gets you the best. And then I actually use a CO2 laser, which so a UV laser though runs like anywhere from $100,000 to $200,000 for a system, right? So
Goodness,
so that is out of my. I love tools, but well, then I even got to use one, and you're like, it's good, but you know, it's not worth the value. So
10 times.
well,
yeah.
in production environments too, though, it's also about how fast you can produce stuff, not necessarily the accuracy, right? I mean, it's about cranking stuff out and making it good enough.
So when you start using a laser, though, you have spot size, right? With UV laser, typically, and then also optics, and also you can typically have a really small spot size. It's usually like 2-micron spot, right?
Wow.
So at least with my setup, I think we're in the I want to say we're in the 20-micron range, so it's a lot bigger. But
so that's like the sharpness of the knife, effectively.
basically, yep. Or it would be, you know, if you had a rod or a dowel. You know, I have a 20-micron dowel versus a 2-micron.
Got it.
And then,
But that's good enough for
for what?
Practically everything but bleeding edge SMD.
Yeah, and then if you're doing prototypes, you know, you know, for the most part, we can cut with the CO2 laser and Kapton. You can cut any package that's out there: BGA, LGA, tiny QFN stuff. I don't know how people do it. I've seen like 0201, 0402. And it's like,
Yeah, crazy.
oh my
yeah,
God.
yeah.
So you can do all that stuff. And then, the bane of my existence is high pin count TQFP packages, right? So,
208, right?
Even like 66 or 100 pin, 200 pin. I don't know what the Arduino do, whatever that giant thing is. I just look at that and cringe. It's like,
But at least you can see and access the pins.
Yeah, and so you can use a stencil and you can go back and you can get bridging, right? Bridging is a good possibility. And so there's some tricks you can do.
Well, that's what solder mask is for. That's the magic of solder mask and the amount of paste you put on. Yeah, if you put too much paste, you're going to, it's all an art.
Yeah. And then, manufacturing engineering is a fickle mistress. So how much does the accuracy matter? I mean, like, do you have a quantifiable accuracy spec that you need to meet in order to? I mean, is it or is it just a good enough? CO2 is good enough. The accuracies are good enough.
Yeah. So this is where I think, as an engineer, I've always prided myself on being able to talk with the technicians, right? And you're doing a little bit of machining. Chris, you might have seen this kind of with your CNC. Yeah. It's like you design something and then you go make it and you're like, oh my God, I can't make this. It's impossible. Or not on this 2-axis machine. I need a 5-axis, but then that costs a lot more. But if you had gone to talk with the technician who's going to machine it or doing it, he's like, oh no, I can save all this cost. So I don't have any quantifiable numbers, but I can do just from rule of thumb that, and then I think I've got close to 10,000 stencils for folks. CO2 laser is pretty good.
Yeah.
So do you offer different thickness stencils? Because the thickness of the stencil determines how much paste is applied ultimately to your pad.
Yeah, so this is, when you look at different business models, I went for simplicity, and seems like 3.5 thousandths of an inch is a standard thickness you can get from most manufacturers, and that covers pretty much the broad spectrum of stuff. Now, if you were going to go into production, A, you wouldn't use Kapton, right? And then
yeah, exactly.
And then B, you would probably have some sort of multi-process setup where you would choose the stencil thickness that would be perfect. But 3.5 thou is pretty good. So you might get some bridging on some high pitch count parts, but then you say, oh, well, it's just a prototype. And the whole focus here is on prototypes, right? You're like, I'll clean it up, some solder wick, no big deal. So versus Kapton's expensive too, and you gotta buy in 50 or 100 foot rolls. So it's a good. So you start stacking that up over multiple. Well, then it's technically by the pound, right? So the thinner it is, the more you get, and so yeah. So just keep inventory low, and 3.5 thousand seems pretty good. So.
So why is there limited life on Kapton stencils? I saw that somewhere else the other day, saying that you can't use them forever. But why is that? So
I mean, it's plastic. You're basically cutting. If think about if you have it's a mechanical structure. So basically between a resistor, you would have 2 pads or 2 openings, and then in between that, it's just a little piece of Kapton that's there. And then, you kind of go over it back and forth, and it's just going to have a lower fatigue life than a metal, right? And then, it's not as stiff. Okay. But for the most part...
Just because you're dragging the paste across it with the little scraper thing.
There's a shear force. Every time you wipe the squidgy across that, stencil, there's a shear force on all those little bridge points. So
I'd say a lot too. It's a lot about how you use it, and then so it's a plastic. So some people would use a metal squeegee, and I wouldn't recommend that. I would say use I found a hotel key card works perfect, right?
And then, credit card. That's a good hack.
Yeah. And then if you're I have a good collection of Subway Cup cards over here. Sure, I'll sign up. Yeah, give me that card.
Yeah, again.
So
all your circuit boards smell like that terrible manufactured bread smell that Subway smell like, though. So what about the fixturing for this then too? Because that was the other question I have. they're not particularly large stencils, right? I mean, there's a limit to the size.
Yeah, so this is, this kind of back when SparkFun first started, and I think Nate, I think it's Seidel, I don't know, Seidel, he had a really good tutorial on it on his on SparkFun site, and then basically he was using the acetate sheets, but really all you need is a flat sheet maybe and some PCBs, excess ones, and some masking tape, and you just slap them down on the table, hold your board so it doesn't move, and then you basically just masking tape your stencil in place. And and kind of back to your earlier question, I've easily done like 100 boards with a single Kapton stencil. So it's all about, if you clean it off and you're just not manhandling it, you're gentle with it. Yeah, you can get plenty of uses, and and then I would even argue, I tell a lot of people, I say, hey guys, if you write back an email after this, if you just put this in a small panel, man, you could you do if it. There's like those Femto-Duino boards, or you got like a little 1-inch by 1-inch piece. Man, put that in a tile, some V-string, man, you could crank out 100 boards, no problem. So, and then it's perfect. It's actually, I would say the Kapton is even good for small production, and you kind of seeing with folks. And a lot of folks do that now with like Tindy, and I'm trying to think of some of those other sites. I saw in Mojo, Jeff Roberg, and the Key Glove.
The Key Glove, yeah. I had that on my list today. Of things to talk about. So, he created a. Did you see that? Did you see that link?
Yeah, he's got it with Google Glass now, or like talking with, I think.
Yeah. He basically hacked the Bluetooth, and he discovered this Key Glove, which is a little control mechanism, and he's able to input all the different commands you could put in on the glass without actually touching it now, including a mouse input or like a little cursor, which is I haven't seen anywhere else yet. So I'm very excited about that.
Well, and he's wicked smart at packets and Bluetooth and I2C protocols and all that stuff. See, we were doing some other stuff with him on. He was doing a lot with the MEMS interface sensor, the InvenSense. They make it's the MPU 9150. It's a 9-axis chip.
Oh yeah. That's the one that a lot of the DIY drones guys use, right?
I don't know. It's actually in the Google Glass. It's.
Oh, is it? Okay. I thought it was the actual. It's not the module. It's a chip.
It's a little IC with got the MEMS. It's got the gyro, the magnetometer, and the accelerometers. And then in that teardown of the Google Glass, was it Star Simpson did, right?
Yeah, Star Simpson.
Yeah, so I was like, 9150. So, but those guys, this goes back to that openness. Jeff basically like re-engineered the protocol because they wouldn't publish their register maps. They're like, hey, here's our magical chip, but we're not going to show you how to interface to it. And then,
wow.
So he was able to like sniff all that stuff and kind of figure it out. So.
Wow.
Now you're a glutton for punishment because you have got yourself a pick and place machine.
That's right, Dave. I thought it was funny when you're like, I will never own one of those.
What is the reason that you'd go out? I mean, like, are you going to start like a board house now as well?
No, no. That's one of those things. Like, what I do want to start, Chris. Though, I want this machine that
chip printer.
Yeah, totally. How did you know? No.
I figured just guests are going to start making fun of me along with Dave. I think we've had a couple already.
I tell you what, you put that on Kickstarter, and I would fund it. So that's
right.
Yeah, the first $1 million sham out there.
So how do you, if you're not going into the board stuff in business, how do you expect to get a return of not only financial but time investment on this pick and place machine?
Yeah, so a couple of things is that, I did this GPS thing before, and so I actually I've made more money doing consulting than actually selling products, just because product margins are so thin,
Of course,
And so I find I mentioned this previously, it ends up being a better advertisement for your work. Like, I think kind of based off your microcurrent stuff, I don't know if you've gotten more interest, Dave, from like, oh, hey, you're really good at power management. Maybe doing consulting or something like that. I don't.
Oh, I used to do lots of consulting, but not anymore.
So I kind of looked at that, and then I wanted, if I was designing stuff, I would talk with people, and then they would say, well, two things they would say is like, hey, we want to design for China. And I was like, hey, you guys, we could get these assembled here in the States, you know. And then I would also argue that I wanted to have the capability. It's like, hey, you want 10 or 20 of these, or maybe you just want 50. Hey, we can stuff some of those boards for you and put them together, and then plus, really, Dave, it's cool. Who doesn't want to?
No, I know it's cool. I want one too.
Ryan, did you just say that you will do small product runs though? Because I think that is like saying that is like wearing meat underwear like near a pack of wolves, right? If you're on the amp hour saying, yeah, I'll do like 10 or 20, that's like raw. You know, like, because it's hard to find places that'll do small quantity stuff and not charge out the wazoo,
right?
You know,
I've kind of looked at it. I guess it would be more. It would have to depend on. So this would be like if I was doing design, like Chris, I would design a board for you. I'd be like, okay, I'm going to do the layout. I'm going to pick standard parts. I'm going to do all 0603, you know, and like, you know, just I can do things up front in the design process.
Turnkey.
Yeah. And then bill for that. So
I see.
So that
makes more sense.
And then I'm also working on. So you guys have seen all these RGB strips, right?
Apparently people like LEDs. Yes, this is what I've determined.
So lots of them. So
yes.
So in addition to hardware, I love, or like, you know, tools. I love LEDs and I love clocks and development boards, right? So
your wife should get an award.
I know. She is pretty awesome. But
yeah.
So I've seen all these strips everywhere, and then Adafruit's been doing them, and there's a bunch of Chinese guys. It turns out the DIY Christmas guys are all about these things. I've learned.
Oh yeah.
But no one's offering. You can buy all these strips, but no one's offering them in a matrix, like a panel. Like a panel, exactly. So I kind of did it for me, and then I designed like a kids table for my kids, and I used this like I bought one of those strips and cut it all up, and so they play like this. I've got it running like Pong, like old school Pong on a 32 by 10 matrix.
Right.
And then, so the kids
nice.
Yeah. And I don't know what it is about arcade buttons, but people love to hit them, right? And so I put arcade put arcade button kids, and Sagan will love this, Dave.
Yeah, for sure.
So
that's the thing. I think kids in general just have the, you know, like the human brain is just dedicated. You know, it wants to see light, and then being able to control that light is just really killer, right? So I think those aspects all together really help.
Yeah,
with LED sales.
Yeah, for people in the know, like like Garrett Mace Tech, and then he's been out there doing stuff.
Yeah,
but he was doing like you could use these TI chips. And then, you know, you could string them all together but you always had to have an LED and then some passives and then an IC, and then you have to gang up a whole bunch of them. And it's like, oh, you can't make it very small. But man, when these guys put the SMD 5050 package and then put the RGB in there with the controller, it's like, oh my gosh, it's like, I don't think of like too many groundbreaking or like revolutionary things, but like to me, for RGB LEDs, this is like a huge leap forward. So basically have the LED in a little passive nanofarad cap, and you're like good to go. And so you just can string tons of those together. So but basically I designed a little 8x8 matrix of these, 10 centimeters by 10 centimeters. So and I almost went bat crazy assembling it, even though I had a stencil and put it down.
Once you set it up, exactly, you want to push the button and you want to see a million of these bastards pop out, right?
Yeah.
That's
so it didn't work like that, though,
huh? So and I was like, had all these big dreams. I'm going to make this huge panel, and I'm going to assemble it by hand. And I was like, oh, this is not going to happen. So it's kind of back to the original business. It's like, hey, well, how could I justify this? And then basically the stencil business is going to take care of itself. And so look at some other options. You got to weigh your risk and stuff. And so turns out pick and place machines from 1995 are pretty awesome with DOS and prices. So
Nice.
And then,
So did you get this on eBay or from a proper second-hand SMD merchant?
Yeah, so there's man, this goes back to Twitter and a little mix of Kickstarter and all this kind of stuff. But Autosport Labs, they did a Kickstarter for like this race capture. They do, I think they like.
Yeah, it's Brent Picasso, right?
Yep. And so I was tweeting. I was like, hey, really want to pick and place. I'm going blind over here. What are some recommendations? And he mentioned this quad pick and place, and I didn't know it at the time, but I guess in the 90s, quad, a division of Echo Electronics they were like the go-to machine, I guess. So, and then so there's a bunch of some folks who basically specialize in refurbishing and reselling these machines because they're a beast. They're like, I don't know. I think Adafruit has like a man-core machine. I think it's a Japanese type, and then some different ones. But these are all they're all using 80/20 aluminum frames. This is like 1,400 pounds of steel. Like
yeah, it's like cut or like drop forged or something.
And then like the table is like 1 inch thick steel, and it's got all these holes. It's like
Sweet.
Oh, this is awesome. So then.
This is like where electrical and mechanical collide,
Well, I think it was Brent that said it.
Servos and air and
Brent was saying it. He's like, man, these would make the most awesomest 3D printer ever because the base is real, and then there's no.
The rigidity is super high, and the servos are really nice. And
then until you see one of these machines, so this little 8x8 would take me about a half hour to place all the parts by hand. It's 256 parts. I can do it, and I just have a single head machine, and I can do it in less than 3 minutes. But when you see this, it is a violent process. The head on that thing moves so fast. So you could, don't disable the safety guards or whatever on the covers.
No.
You stick your hand in there, it's going to eat it. None of this
it's going to go. Yeah.
So.
Well, yeah, and the upper limit of that stuff too. It's like, I mean, people can go on YouTube and just look at the insane speed of pick and place machines, and because I mean that alone, just a 95 one is fast, right? Because that was the top notch for the time. But now it's just like. I mean, they're just shooting parts, It's just insanity.
Well, Dave, you had that video where you went to your assembly house, right? With that.
Yes.
And he had like 6 heads. That thing was like awesome.
I know. Yeah. Yeah, and it cost $500,000.
Right.
Yeah.
But in 15 years, it'll be less.
Right. Well, so that's the thing is like this quad machine, I guess, went for like $100,000 back in the day, right?
Right.
And then
how much does it cost these days? How much do you pay for it?
I paid.
Tell us the price, son.
I paid top dollar. I paid just the base machine because you could also get feeders, right? So we were
of course.
Yeah, and then so I got a machine that had been basically stripped down and rebuilt, and then they replaced a number of things on them, like high wear parts, and make sure all the slides. So I got to work through one that had been gone through, and I paid like a little over $16,500.
Oh, that's not as bad as I thought. I was going to guess 25.
Yeah, but
that's good. I mean, like because you got one that's like guaranteed, right? I mean, you could spend easily 3 months trying to fix one up.
Yeah, so
you basically priced in the guarantee of it working.
Yes,
and hopefully guarantee from the manufacturer.
Dave and I agree on this, at least from the podcast. It's like I bought a machine and I want it to work. Just. Like with the laser, I bought a nice laser. You didn't have to get a laser as nice as mine, but you know what? When that thing breaks, Epilogue overnights me a part, and it's there, and I put it on, and I talked to a technician in America, and they said this works, and then so that's kind of what I went.
Big difference.
Now you can buy these machines.
On eBay, sight unseen kind of, here it is, take your chances, And I don't know, it turns on and the lights come on. Kind of. Yeah, good luck.
Yeah. And the other thing was these guys, they had training, and they were real big on like, hey, come up to the facility, make sure this is the machine you want. We'll run your parts. And it was like, oh, thank God.
That's essential.
Yes.
That's essential. Really.
And then I've been pretty fortunate in my military career, just like with the having access to like LPKF and these nice machines, and like LPKF comes out 3-day training session. It's like a big deal because the machines are complicated, and often you need a technician dedicated to that machine, right? And then so they learn the ins and outs, and everybody says it'll do the dishes and fold your laundry, in the sales pitch, but then you get it and you're like, oh, this is a lot harder than I
I've got to
thought.
spend my life in front of it pushing buttons.
Right,
That's right.
And so
Or you have to relearn it each time you come back to it. That's the worst one, where you go away for a day and a half and you're like, what the hell is this thing? What about this Taobao? You have a Taobao shown that we've talked about on the show before, the smaller $4,000 pick and place, but you decided against that? Why was that?
Yeah, well, so you can get one of these used quads for like right around 10K in really good shape, right? So the 10K, and then you can spend more to make sure it works and blah blah blah, and be at the 15 per se, right? So kind of depending where you are, but the Taobao is really interesting, but it's kind of expensive.
It's not cheap. What is it, $4,000 or something for that?
Yeah, like 4, and then I think by the time you have shipping and like a spare
Imports and
parts
stuff.
kit, it's kind of it's right at the 5.5 range, it seems.
And then it's kind of not really there, in terms of the performance and what you want to do.
Well, no one's coming out to train you on it, that's for sure.
Yeah. So you can end up buying a $5,000 white elephant.
Oh, I agree. And then so these systems don't have machine vision, right? So what I found, there's two types of vision. There's obviously cameras, but then there's also laser alignment. And so at least quad, it'll pick up a part. So here's a couple things. It's like when you get things in a reel, it's like these are all practical things. There's tolerance. It doesn't fit in there tight. That resistor floats around. So so you got to line it up to place it, and then so that's when you want. I learned this with the laser measurement. You want a through axis camera. So basically, you get to see what the vacuum pickup in this case, or the laser, is doing to align it, right? So that's one key thing you have. So the Taobao does not have that. I think some guys have hooked up a laser pointer somehow, and with an XY offset, and kind of back it out, I think. So that's one thing. And then, so at least the quad will pick up the part, and then it'll actually turn it 90 degrees, and it uses like a laser line to basically measure it. And then when it measures it, it knows the orientation, like a theta offset. So if it's, kind of came off there twisted, and then it will know if it's XY offset as well. So if it didn't pick it up exactly in the middle, it'll correct for that when it actually places the part. So that's
because it's a real pick and place machine as opposed to one of these toys. Right. Essentially, they're just a high end toy. The Taobao.
Oh yeah, closed loop versus open loop, right? I mean that's effectively the difference.
And I think probably if you had some bigger parts, like if you were like in the 1206, or is it 802? What's the one down from 1206?
805.
Yeah, 805.
Oh, 805.
Yeah, you could probably be in the tolerances of the solder paste and the like when you reflow, it kind of wiggles back into place. You see?
Yeah, the surface tension.
The surface tension pulls the part into alignment. Yep. That's what you have to rely on there.
Right. Yeah. Not the best thing, because then if you've got a stencil that's nearing an end of its life, right, then you might be that kind of same thing, right?
Well, and I'd say with the stencil, it's you can spend a lot of money on a stencil printer. I'm amazed at that too. But that's of all the processes, surface mount is very forgiving. As far as alignment, and then hot air reflow is so much easier than going back with the trimming leads off of through hole parts and
and wave soldering.
Yeah.
Or solder pots. Those things are little fountains of death. Although I just saw one recently that was actually like a really it was just for doing like wire tip ends, like just for tinning the end of wires. It was really cool. It was this little cute thing. It was like $100. It was a little cute solder pot. I had never seen one that small before. I always thought like the big massive desoldering,
Yeah, you can
big QFP through hole stuff.
Yeah. Yeah, so I really I hate through hole, so that's
You don't like getting poked through the finger?
Yeah.
You don't like the little tuberculosis test every time you pick up a board?
Yeah, so that it doesn't have vision, and then it doesn't have this laser alignment thing, and then the other huge thing. So this I learned this in my PhD, but with the LPKF laser, you're doing multiple parts where they have to be aligned. Basically fiducials, right? Fiducial alignment. You have to have a vision system with anything because boards. You get them. You send off your design and you get it back in the mail and you're like, it's magic and it just appeared. But it's like it's not magically straight. Pretty straight, or it might be. Boards can warp and do all sorts of different things, and you got to have that. A 10,000th off alignment when you're placing a part could mean whether your pad's on the your passive's on the pad or if it's not, or tombstoning versus not tombstoning. So so that's kind of what I wanted. So it basically eliminated it. If it was like maybe like $2,000, I'd probably be in, but
right, yep,
it's kind of like that magic threshold where
no, you either go all in and get a real pick and place machine, or you don't bother. You're better off just farming it out to somebody with a real pick and place machine.
Yeah, and those things are slow. When you compare the speed, it's just like, So, but yeah.
As I said, there's always a very narrow niche in there that this machine is applicable to. It's a very narrow niche, bordering on no niche at all.
It's
a toy.
Vanishingly small. It's a
yeah.
It's an integration over a very, very small place.
Yep, exactly. So, how many feeders have you got for this bad boy? That's where I had to open my wallet again.
That's the tooling. That is the tooling to the machine.
Well,
right?
and then it's like, gosh, I was like, I wish I just see. I don't know if you guys. I hate NRE fees, non-recurring engineering fees. It's like you get nickel and dime. That's what I feel like. But now that I have a pick and place, I get it. Right? It's a pain. It's a pain in the ass to set up.
Right. Right, because if you have 20 slots and if you have 20 feeders and you put 21 parts on a board, you have to redo your setup. Right. That's the idea, and that's another part of design for manufacturing is like you want to minimize your part count because that helps lower your overall cost.
Right.
Well, to me, it's not a big deal. Like I'll get charged, $250 setup for my board, to actually set up the machine. And I don't think that's a big deal.
That's really good. I'm usually like in the $500 range on quotes that I've been getting, and it's like,
Right. But still, it takes some poor bastard all day, right, to actually do this. So, it's, how much do you value your own time?
And that's where, like, at least for these RGB matrices, so I'm actually making sell these, but for these, basically, I just set up two parts, the LED and a passive. And in that case, I was like, I'm not paying NRE fees. But, if I had to pull my feeders off. So I ended up with 12 millimeter feeders. And then, 8 millimeter. I'm totally guessing. Whatever 0603 parts come on. I got a bunch of that. I got 8 of those, and I got 2 big ones for the LEDs. So I didn't go crazy. But, man, feeders, it's like $200. As a starting up to 500, So.
Well, there you go. I mean, you're limited to only 10 different parts. I mean, that wouldn't even do most of my designs.
Right.
It's like, if you have a specific need, like these LED boards, right? You've got LEDs, you've got a driver chip, you've got a bypass cap, and, and not much else, really. I mean, even a small number of feeders is going to do it, but any sort of moderately complex board is going to require, 20 feeders, for example. 10 is probably not enough.
Don't quote me on this. I'm sure there's more experts out there. I got the impression that there's some board houses that will actually not unreel your parts. They will just keep the feeder, like the whole setup, right? And they'll keep it and then just store those and then put a whole new set of feeders in. And I was shocked.
Yes, they do. I show that in my video. I show a rack, and they have a big rack of hundreds of these feeders, and they keep the components loaded in the feeder. And they just whack the feeder in.
Yeah, when I saw that in your video, my jaw dropped. I was like, oh my God, they're going to have so much money. And they had some crazy feeders for your stuff too. So when you start getting to...
Yeah, well, that's the other thing, right? If you want to place something simple like a surface mount 2032 battery holder, right? You need a big, expensive, wide feeder to do that because these things come in, 1.5 inch wide tapes or something. Right, you need a specific feeder for that. You need, if you want to put a Y connector, just a 0.1 inch surface mount header connector, you need a big, a 3-inch wide, and you want it, 26-way connector. You need a big 3-inch wide feeder.
Special
just
tapes,
just for a bog standard part like a 0.1-inch header connector. It's crazy.
Well, but it's better than the alternative, which is hand placing, right? I mean, sometimes they do that, but yeah.
Well, sometimes they do that, but I mean, if you want to take your pick and place seriously, as I said, if you're trying to do just any old board, well, you need a very complex array of these feeders.
Yeah.
So, it's
so good luck
tough.
with all that,
Yeah,
Ryan.
so
Yeah, exactly. Good luck if you do anything other than a lead board,
Dave, you can send me my boards, but they will not have as battery holders. Because that's probably like a $1,000 or $2,000 feeder right there just for that part, and it's like,
yeah, exactly.
So.
Bang.
You know what you do is you include the battery holder and then you say, it's a kit.
It's a kit.
Solder it
that's
yourself.
That's it.
I totally see that a lot. Well, who's Wendelowski, and he's really good at making their. They use all their through hole parts, and I think it's genius that they just say, hey, you're the customer, have fun, and so.
Yep.
Yeah, there's downsides to that though, because then you have to try and source all through hole components, which is getting more difficult.
Right. You just got to find your niche, and and kind of go with it. And so I'm trying to avoid that. And if I did offer an assembly service, it would be like, hey, here's the design rules, all 0603 parts, and then
Here's your available parts.
Here's your available parts.
And you would have no life left, and it's a mugs game. Assembling boards is a mugs game. It really is.
And
Sorry to all assemblers.
Basically, I'm telling you, don't do it.
I appreciate that. So.
What you could do is you could if you did it like a recipe or like a today's specials are, like you go to a restaurant and they say, oh, today's specials are the Reuben sandwich and the grilled cheese, right? If you put up on a board, here's what I have on my machine today, what can you make? And you have to have it here in the next 24 hours. That would be an interesting business,
right? That's interesting.
Because then you could do it, right? I mean, it would just be a programming file.
Yeah, it wouldn't be much hassle.
Was it Woot, right? I have a Woot off, right, for a assembly?
Yeah.
Right.
There'd still be a lot of processing there, but it would be. That'd be an interesting idea.
I will say this. I don't know about you guys, and I think, even our setup for today's show, you guys have learned a ton about audio and recording, and it's kind of like, where do you draw the line as far as but having a pick and place has definitely made me a better design engineer for manufacturer of parts, because I was like, oh, hey, I got a pick and place. Oh yeah, that requires a nozzle change. Don't put that part in. Keep this other one, or different things like that. So
yeah, you create like mental constructs basically that where you know how to steer your design decisions based on that. And it's tough at the beginning, right? I mean, I remember doing designs as like in college, right, and doing like a layout and being like, oh, of course, why not put like a huge power plane underneath this thing that I'm going to want to desolder a lot, right? It's like,
well, so Chris, is a good segment or segue. Is I think kind of what you're doing with the contextual electronics kind of thing is pretty awesome, because just even with my PhD work, I don't know, I was surprised how many PhDs in electrical engineering had never laid out a circuit board ever.
Yeah, I hear that a lot. I mean,
it's practically 100%.
It just like baffled me, and so people would come to me and say, "Hey, man, I heard you're really good with this stuff." I was like, "Where'd you hear that?" Because I'm in the I'm in the aero department. I don't even know who you are. So, but
it's like a drug deal going down. You're like, hey, buddy, can I get a hit? Yeah. Can I get a hit of layout?
But there's such a lack of practical knowledge when it comes to which I think should be an essential skill. So I think but where do people get it now these days? I don't think they're getting it at university, right? So where do you go?
Co-ops. Co-ops is how I learned a lot of it, but hopefully contextual electronics is what people say in the future. We'll see. Thanks for the sales pitch, by the way. I owe you like $5 or something.
Yeah, no, I think it's good. So, well, and Dave, that's I think you guys were talking on a previous show about interviewing. Was it interviewing co-ops or was it interviewing for resumes? Maybe. or for job applications, asking people, I've asked interns, hey, what's this amp amp? What's the gain on it? How do you do the blah, blah?
Those basic questions, to weed out the dummies.
And I was like, I'm a mechanical engineer. I just read the data sheet, like, hey, I
see, but right there, even just that, like, I read the data sheet. You'd be surprised how many people are like, the what?
Right. Exactly. Bingo. You've just passed the first test. You know?
Right.
Yeah.
Hopefully it'll get better. We'll hopefully. I think a lot of it will. I mean, like I think you're a great example of, you kind of bridge the gap between the consulting world and obviously the military career is very impressive as well in your research. But then also you get into the DIY stuff as well, and that's like perfect cross section of our audience right there, right? And I think it's the DIY section that pulling that towards the academic side and just kind of getting people started making stuff younger and experiencing it younger is going to be the really key thing. I don't know, like when did you start building stuff? That might be a good question to ask.
And I think that the maker movement or whatever you would call it, I think there's always been people that make things, and some people are better at teaching themselves how to do stuff than others. And I just learned electronics because no one told me this in school, was that I learned quickly as a mechanical engineer, if you want to, you're concerned about stress or temperature or whatever it is in your parts. Well, how do you get that information? Well, you put a sensor on, and what do you do with that sensor? Well, it's powered electrically, and then, well, now you power it electrically. How do you record the data? And then, so it started with.
You go get your EE friend, of course, right?
So you, but So I quickly learned that, hey, software, I did a lot of design and analysis. So software, you got to learn, some people might poo-poo this, but first real language I really learned was MATLAB, right? For an engineer, that's a pretty common language, but it's all high level because, at the end of the day, you're like, hey, I just want to know, I want to invert the matrix. I don't care how it's done. I don't really care if it's the fastest process, but
yeah, exactly.
So you do that, and then, okay, so now I'm going to design my part. Now we're going to go do it. So I worked in a test facility and did different things, but I quickly learned, you got to interface to, LabVIEW or some data acquisition, and then, so you take your data, now you know the stress, but now you need to automate that, right? So I'm real big on automation because I'm lazy. And
but the sign of a good engineer, by the way, I think.
Yeah. It's so you do this. So you learn, learn MATLAB. You got to, learn about powering your circuits. We did a lot with RTDs and platinum RTDs and thermocouples and all the conditioning circuits and cold junction compensation and blah blah blah. And so basically, I just had problems and it's like, oh damn it, I got to learn something new again to solve my problem. And so, it's all.
He said sarcastically while actually loving it.
But I think in some ways, you talked about, people learning. I think it's actually going to be hard for people to learn, young people to learn academic electronics, because academic electronics is kind of boring. And then I think you mentioned this in one of your previous shows that there's a chip for that. All you do is wait a couple months, and you're like, I wish there was a magical chip that measured temperature. Well, yeah.
Hello.
Maxims came out with a new one this month, and it's smaller and lighter.
Yep.
So.
And it costs $3. Yep. So. Yeah. It sucks and it's awesome. Right. I know.
So a lot starting out electrical engineering to me was a lot about like just connecting the dots. It's like, oh, net list. Oh, okay. Well, just connect the dots. So power.
That actually is connected.
And then, so I don't know. Well, I think it just kind of opened. Yeah, go ahead.
Well, what about going forwards? I mean, like, are you? If this became a full-time business, is it like you're military for life?
Yeah. What I realized, I don't know. I'm actually impressed, Dave, that you're doing this full time.
Thank you.
Yeah.
So am I.
I don't know if I'll ever be able to make the transition. And then, just talking with folks that are successful, the people I know who do consulting have their hands kind of like in everything, right? So maybe they do some design, maybe they do some assembly, they do some contract work, they work for the man, at certain periods of time. Mm-hmm. But I personally, right now, I don't see being able to provide. I got a wife and kids, and then there's also, what level of lifestyle do you want to have, and having a full-time job.
Yeah.
It's a nice lifestyle, even though I'm upper middle management right now, but the good part of the.
But you can go home at 5 o'clock and forget about it.
I agree. And then
go hang out in the garage for until 2 a.m.
Yeah. Or I do a lot of that, right? So, but the business is also, I have a room and a garage full of pretty awesome tools, and it pays for that, right? And so my wife doesn't care as long as the business pays for itself. So, yeah.
Right.
But
making the full-time jump, I don't know. We'll see.
Well, it's like what we talked about before, right? I mean, Dave has said, his hobby became his business, and now
you'll find that you probably don't have to make the choice. It's not like you'll wake up one day, right, I'm going to do this full time. It'll just happen. It'll just, naturally happen, I think. Well, either it will or it won't.
Well, Dave, I don't know.
It's I think if you have to make that big choice, then you're probably doing it wrong.
Well, have you guys seen this? I just kind of started this as an experiment because I've seen people more like in the military side where they get out and they're like, I'm going to start a business and, selling ice cream cones.
Yeah, right.
Like, you don't know anything about ice cream, and it's like, and then,
right.
and I was like, oh, I kind of, like run an online business. Everybody thinks like online business, that's magical. It's like, no, it's not magical. It is a very
pack and ship.
It
sucks.
is hard. Yeah. I have all new respect for the shipping department now. I was like, I was so mean to those guys. But I was like,
almost every internet business is a huge logistics business. Like when Phil and John Janier were showing me around Aided Fruit's headquarters, just everything there is shipping. It's just and their build out is all shipping. It's very, very impressive, and I notice it now too. If you doing high volume online sales, it's not easy. Not for a second.
And so and then just running credit cards and doing all sorts. I was like, all these things that are associated with running a business. I'm glad I learned them now because. I can't imagine the guy, just getting out and is going to learn all this stuff from scratch. And it's like, man, and feed your family, so it's like,
yeah. Right. Yeah. I'll sell ice cream cones with a 3% margin. And then Visa takes 3%. Oh,
crap. Right. Well, and I've been, you guys talk a lot about Kickstarter, but I've been watching and following that. I might do something here soon. But, when the big thing is, people say, oh, here's the product, and then shipping's free. I was, oh my gosh, shipping's so expensive. And,
yeah, right. Mm-hmm. Unless you're shipping thousands and you already have an agreement in place.
And a lot of
it's insanity.
People, you don't realize too is that you ship a product and then if it doesn't get there, you're paying for it. Not
you have to eat it. You've got to factor in a 5% loss or something. Just there so that you can, because the last thing you do is argue about it. You just go, look, I'll ship you a new one, and then you just, that's just all part of your expense, really.
Retail prices in a 10% shoplifting rate, as does Visa for 10% fraudulent claims. It's crazy, they just write it off. Oh well, whatever.
Yep. It's
we'll,
not
we'll
worth
make it up in
worrying about.
fees.
Exactly.
So, but if I had,
oh boy,
yeah, go ahead.
So. No, I think I just said, I think you'll find that your business will eventually become big where the obvious choice is, that, you won't need your day job anymore.
Now, Dave, I have a question for you.
Yep.
Have you found that since because I love beer, right? And everybody brews beer. They're like, don't start a brewery if you like beer, right? Because you're not going to do it. And so I was curious where, obviously with your videos and stuff, but does it take the enjoyment away now that you're doing it full time?
It does, and it can, yes. I mean, I just took 3-4 days off, right? That's the first time ever. I just did nothing for the last 3-4 days. I've had the flu. I thought I'd recover, right? And I just did nothing, and I felt so good that I just sat there and there was no pressure because... That's the thing. Now that there's, it's been my full-time business for 2 years, and yes, there's constant, continuous pressure all day, every day to produce new content. And in the last month, I produced 15 videos. In the last month, 9 hours of material, in the last month. And that's it's a lot of continuous pressure, and it can take the fun out of it. So yeah, it's you have to be very careful.
You get a lot of mailbag PCBs, but you don't have as much time to put them together, right? So there's less fun there, like that kind of thing, right?
Yeah, exactly. I would love to just sit there and build some kits or work on my projects or whatever. It's like I've got 2 or 3 projects that I'm working on. Do I have time to work on them? No, because I'm spending time keeping all of my customers, in quote marks, happy with continuous videos. It's
So what Dave says is he quits.
Right, I quit. But then again, would I give it up and go back to a full-time day job? No. Hell no. Right? It's unfortunately, it's not a free lunch. You have to pay a price for it. And the price, in my case, is continuous pressure to produce videos and no free time. So, well,
that's why you can keep other hobbies though too, right? So Ryan, you do beer, you make beer as well? I mean, like
every now and then working out and staying fit, it's all life balance and family. And so, that's all those things. And my big thing is my PhD. I had a taste of the good life, Dave, where I definitely worked more than I did at my standard day job on my PhD, but it was when I chose to. So
exactly.
So if I wanted to wake up with my kids and eat breakfast with them, I could do that. And then I could stay and have lunch with them too, or I could take them to the pool.
That's why I would not give up this lifestyle to go back to the day job, because yes, I have the same flexibility. As I say in the video, if you've watched the video of me talking about my full-time video blogging business, the little 5-minute routine I did, I said you can work any 12 hours a day you want. That's you have the flexibility. If I get up in the morning and I go, screw it, I couldn't be bothered doing anything today, I'm going to go play with Sagan all day, I can do that. And the world's not going to end. But ultimately, sooner or later, sooner or later, you've got to keep producing the content. And in your case, if it's beer, you went in the beer business, well, you've got to get out there and keep producing the beer. It's a production business. So is I'm in the video production business. And I have to continually produce video. So, yeah. And
it's weird because you start to focus on different things, right? So like with beer, I can imagine you would become like an art. Like there was an XKCD comic, right, where he talks about there's no field where you can't become like a snob about it, right? And so like beer might be like hop varieties or whatever, but so you just lose that enjoyment of discovery, and it becomes more of a become an expert in a certain field, right? That kind of starts to stink.
Well, I've seen this back to, we follow in blogs or different things, and you'll see layouts, right? All this open source hardware, right? So you see the layout, and you're like, oh my God, I would never lay out a board that way. Or, Dave, in your videos, you're super critical of, different stuff people do, and you're like, and it's like you're not trying to be, provide negative feedback, but it's just like, oh man, these are simple.
I've seen the T-shirt.
That's
I don't know.
That's who I am. I can't help myself.
Yeah.
Oh boy.
Well, I mean, it's just so finding that balance is the key, right? And if you can do it, but so I had the taste of the good life, and then it's like, man, I want it back because I'm not. Military, we get up early. You got to be there on time, and I hate the look. Maybe your kid's sick or something. So you don't come in right at when you're supposed to, 8:30, or I don't know, whenever it is. And then people say, "Oh no, that's cool," but they don't really mean it. You know what I mean? Yeah. Oh.
Yeah, of course.
Social pressure.
Yeah.
Yeah. And so, and then I do like. I've seen a couple different articles on how engineering's a creative process, right? And so for me, I'm not creative in the morning. I'm creative in the late evening. So if so it's balancing that. So, no one knows when you're staying up late working on a project. They just see that, you didn't come in at whatever time it was that you're supposed to be there. I just, right. Yeah.
They assume you're drinking beer.
I wish. Yeah.
And you might be, but you're also designing circuit boards.
Yeah.
Delicious, delicious circuit boards.
All right. Well, thank you very much, Ryan. Your amp
thank
hour
you.
is up. Way exceeded, as usual.
So, where can people find your stuff? I mean,
I guess two things I want to put out there is that the website is ohararp.com. So just OHARA and then RP. So think of my initials.com. And then
see, I thought it was like Open Hardware Arab
that'd be
or
good.
something,
Yeah.
I just didn't get it.
I need to put a bit
Now I do.
up there
All right.
on those silly network admin guys.
It's a good idea.
So we're working on this other project. It's RGB-123.com, and so that's still pretty early on, but we'll see how that goes. And then I would also put out two things I want to put out is Chris, we'll have to coordinate, but I definitely want to give a coupon for stencils and stuff to all the listeners. So maybe we can put that up on the webpage later.
Yeah, all the listeners.
Yeah,
Careful.
Well, yeah, I say sure. Sure, why not? I'm a giving guy. So, and then I would say if anybody wants to contact me and has questions, Twitter or whatever. I want to try and give back and to the community as much as possible. There's that's probably one of the best parts of all this. So
very cool. All right, well, we will give away a coupon for free. Was it free stencils, right? No, I'm just kidding.
We'll look at a good 20-25% off or something.
I know. And Chris just ruined Ryan's business.
Yeah.
All right.
He's already raised a thin
Right, yeah, exactly.
Yeah, exactly, right?
Hey.
Chris is going to have to throw in for some extra Kapton this month. The Kapton budget just went up.
And he's just calculated he's working for $1
that's
an
right,
hour.
that's right.
Yep, exactly.
But we did say free assembly though on the pick and place, right? Yeah, that's right. It was. Yeah.
Oh yeah, right.
Right.
That'll be the worst when people start asking you about the proto runs. Yeah, that'll be much worse than the coupon. You asked for it. Thanks for being on the show, Ryan. We really appreciate hearing about the stencils. That's cool, and I think you're doing some great work.
Well, thanks again, guys. I really appreciate it. And keep up the show. I definitely impressed.
Cool.
Thanks, man.
Thanks, Ryan.
Talk to you later.
Catch you later, mate.
All right, take care, guys.